right, welcome back. We're going to continue with factoring, but now I'm going to write factoring special cases. So factoring special cases, we're on page 30 here. So there are two special cases that we're going to talk about. And the first one is going to be called difference of two squares. Okay, so difference of two squares. And we're just going to do an example. And it could look something like x squared minus 49. Okay? Now we're going to factor this the exact same that we have. Just, I'm sure that all of you realize that it looks a little different right now. Okay, so let's see what we should do. Well, we always start with our area model. And we put our first and last term in the corners, which we have our first term and our last term, and we multiply, just like normal. Okay, now let's think about what should go in the bottom. Well, what's our middle term here? Our middle term is 0. So I'm going to write 0x here. And then I'm going to put when there is no middle term, 0x goes in the bottom of the diamond. Okay, so it's the same process now. We're multiplying to negative 49, adding to 0. What multiplies to negative 49 adds to 0? Well, that's going to be negative 7x and positive 7x. Negative 7 times positive 7 is a negative 49. Negative 7 plus 7 is that 0. So that's what goes in the sides. And then we figure out our GCFs. X plus 7, x minus 7. So our factored form is x plus 7, x minus 7. Okay, and obviously that looks a little special, right? We have 7s here. And then I'm just going to write what this equals our original problem. Okay, now it's called a difference of two squares because if you look at this original problem, x squared, you can take the square root of that. The square root of x squared is x, and you can take the square root of 49, and that's going to be plus or minus 7. So that's why it's called a difference of two squares, because you have two squares with a minus in between, and that's how it's going to end up. Okay, it doesn't change the problem, it's just a special case. Okay, but this is a property I'm going to write down. So the difference of two squares property is if I have u squared minus w squared, just like this, that's going to equal u minus w times u plus w. Okay. That is not something you have to memorize. If you'd like just factoring it, that's perfectly fine. I just wanted to tell you what a special case would be. Okay, and now the next case that's special, it's going to be a perfect square trinomial. Okay, perfect square trinomial. So let's do an example just like we did. Okay, 4x squared plus 20x plus 25. And again, we're just going to factor it like normal, okay? We always start by looking if there's a GCF. So 4, 20, and 25, they don't have anything in common, so I don't need one. And now I make my box. First and last term. Multiply. That'll be 100x squared. And we're trying to add to that middle term, which is 20x. Okay, multiplying to 100, adding to 20. Multiplying to 100, adding to 20, what do you think that would be? Hopefully you guys wrote down plus 10x plus 10x. 10 times 10 is 100. 10 plus 10 is 20. Okay, so I'm going to put those here and here. We find our GCFs here. 4x squared and 10x have a 2x in common. These have a 5. These have a 2x. And these have a 5. Okay, so we have 2x plus 5 times 2x plus 5. Well, those are the same thing. So I can actually write this as 2x plus 5 squared. And that's why it's called a perfect square trinomial, because you can write it as a squared. Okay, and it doesn't change anything. It's just one of those special cases. Okay. And this one has a property as well. It's u squared plus 2uw plus w squared equals u plus w squared. And we can show this using this example. U would be 2x actually. W would be 5. That's why it's 2x plus 5 squared. Okay? And those are your two special cases of factoring.